To solve an equation with variables on both sides, the first thing you want to do is make sure each side of the equation is simplified, just like we did in section 3.3. So that might mean combine like terms or do distributive property. Once that happens, the next thing that you're going to do is you're going to get your variable terms together on one side of the equation by either adding or subtracting. Those are your only options, and you can move whichever variable is going to be easier. Once you've done that, you're going to solve like normal using reverse PEMDAS to isolate the variable. So on that first example there where it says 7 minus 8x equals 4x minus 17, there's no math to do on this side because you can't do a 7 minus 8x, and there's no math to do on this side because you can't do a 4x minus 17. So I either have to move my 8x from the left to the right or my 4x from the right to the left. If I wanted to move the minus 8x to cancel that out, I would do plus 8x. And if I wanted to move the 4x to cancel that out, I would do minus 4x. The easier one to do, it would be to do adding. Most people prefer adding over subtraction. So here, those would now cancel. Bring down your equal sign straight down, and you're left with 7 equals 12x minus 17. So now if you solve like normal, you're just going to add 17 to both sides, and you end up with 24 equals 12x, running out of room. And if you divide both sides by 12, you would get x equals 2. Try these 3 examples, pause the video, come back to check your answers when you're done. On this one right here, it's really important to note that the easier option is to minus 2x from both sides, but by minusing 2x, that's only canceling out that. So you're still left with a negative 7 because that's the sign of 7, so make sure that comes down with it. And then after you minus 13 and then divide both sides by 3, your final answer would be x equals negative 20/3. You could change it to a mixed number, but there's no need to. So on this one right here, once you distribute, you minus 4x from both sides, add 5 to get 20, and divide by 5 to get x equals 4. And on this one, after you distribute the 1/5, the easiest thing to do is minus your 1x, and then go from there. One thing to keep in mind is I actually did it here the first time I did it through, is I went to go minus 4 the first time. Once you're ready to move things from one side to the other, it's always best to really move your variables first. In the end, it will actually just look a lot better. It will make it a lot easier for you. So after you've done everything you can do on each side, whether that means distributive property or perhaps combining like terms, the variables are the very next thing you want to deal with. You're going to skip the word problem and just go right on to the next slide. So right here, this is kind of the heart of what we're going to be doing in this section with variables on both sides. Solve really means to find the value of the variable that's going to make the statement true. So when you're solving an equation with variables on both sides, there's a couple possibilities that can happen. The first thing, that an equation can have one solution, and for example, one of the problems in the previous page had a solution of x equals 3. So this means that the only possible number that could work for x is 3, and that's the number that if you plug it in, the equation is going to work. There's nothing else that will work. There's one possible solution. It's also possible to get no solution or all real numbers, or in this case it could be infinite solutions. The key is that anytime you're solving an equation, you're not done until the variable is isolated. So you always want to make sure that you're trying to isolate the variable. So let's look at this example down here and see what happens. So the first thing we would do is distribute the 3. So we're going to get 3x equals 3x plus 12. And then because I've done that, there's no more like terms, I'm ready to go. The next thing that I'm going to do is combine my variables by moving one to the other side. I bring down my equal sign straight down. Those would cancel, so I'm left with 12. And over here, 3x minus 3x, they do cancel, but they actually cancel and become 0. So it looks a little funny because 0 doesn't equal 12. So it doesn't tell me anything about x. Like, it doesn't say that x can be 0. It doesn't say that x can be 12. It doesn't say anything about x at all because the x went away. So I'm going to have to interpret that in some other way. Let's look at the one over here, and then we'll kind of compare the answers and see which one we think is which. So over here, I'm going to do the distributive property. So I'm going to get 2x plus 10 equals 2x plus 10. And then I'm going to minus 2x from both sides because once I'm done, I do my variables first. And I'm left with 10 equals 10. So this one's a little bit different because here, 10 actually does equal 10. And over here, 0 didn't equal 12. Neither of these have a variable anymore. So this doesn't say that x can be 0 or that x can be 12. And this doesn't say that x can be 10 either. Just this kind of gives us a true statement, and this gives us a false statement. So what we're going to mean that take that to mean is that if we get a false statement, we're going to say no solution. Because there's nothing that x can be that would work. And if you kind of look back here, you can see that on this side you're multiplying x by 3, and on this side you're also multiplying x by 3, but then you're adding 12, so it'd kind of be like an unbalanced scale. In this problem, where 10 equals 10, your final answer is going to be any number or all real numbers. You could say one or the other. Any number or all real numbers. Because no matter what you do, or what number x would be, you're multiplying both sides by 2, and then you're adding 10, so it would always be balanced. So no solution, you're going to say when you get a false statement, you would say no solution. And all real numbers, that's what your answer if you got a true statement or something like 2 equals 2. So your answer is going to look one of 3 ways, which is really important to keep in mind. Your answer is either going to be x equals a number, or it's going to be no solution, or it's going to be all real numbers. That's what you'd write on your paper. So try these 4 examples, see what you come up with for an answer, pause the video and come back to check when you're done. So on this example here, after you distribute the 5 and then minus 5x from both sides, you get negative 6 equals negative 5. It's a false statement, so there's no solution. There's no value that x could be that would work. Over here, after distributing and bringing your x's together, you get 8 equals 8, which is a true statement, so all real numbers. The one right below, you distribute your negative 3, add 6x to both sides to combine them. 21 doesn't equal 24, so we end up with no solution. On this one right here, so I distributed and then I minus my 12x. So I get 18 equals 6x plus 18, which I just brought down. Sorry, I ran out of room. Then I minus 18 from both sides, and I actually didn't finish yet, but I wanted to show you that we're not quite done. So the reason that I know I'm not done is because x isn't isolated, and your goal is to always isolate x. Now sometimes, like up here and up here and up here, the variable disappears. But I haven't isolated x yet. I still need to get rid of the 6. So to do that, I would divide both sides by 6, and I actually get x equals 0, which is my answer. There's one solution. There's one number that x could possibly be, and it's 0. So I'm not going to say no solution, because there is one. It's 0. I'm not going to say any number, because any number wouldn't work. The only number that would work is 0. We'll finish the rest in class tomorrow, especially the word problems.